Good afternoon, ladies and gentlemen, and thank you for joining us me today for the webinar just to go through the Monodraught, mainly the Monodraught HTM performance components that's now available in IES 2017. So today we're going to mainly run through the new navigator that's available for the HTM system in 2017, giving a little bit of background about the system, its main functionality, and then the step-by-step process that is involved in inserting into your IES models. We also have a number of other IES components for our systems in IES, such as the cool phase systems and the Winkat systems. We'll also touch on those two items a bit later on in this webinar. But throughout the process, if you've got any questions as we go through, then put them through and I'll do my best to answer them. And also we'll try and get the recording this webinar as well, so we can share the link so you can run through it again. We'll also be providing links to the YouTube videos for our user guides, which will give a visual demonstration of the process about the way to assign the systems into the models. So we'll start with the HTM components. So I've got an IES model prepared here on the screen, which I'm going to assign. And quite simply, to access the systems, if you click on the navigators section in IES, and then if you don't have the HTM navigator come up automatically up here, if you go to the drop down on the top left hand side, and under the partner section you'll find Monodraught HTM, as well as such as the Monodraught core phase system as well, which also uses the navigator function. So clicking on the link there, and it'll bring up the information about the systems. So to start off with, what is the Monodraught HTM? Well, this was primarily developed to meet the UK's Priority Schools Building Programme for constructing new school buildings throughout the UK. And with this building programme, the EFA also brought out a number of new design criteria for the schools to be designed to. So then obviously the systems are developed to meet all that new criteria, the foster facilities output specification. So the main function of the HTM is to provide a little bit of natural ventilation into a desired room, as well as boosted fresh air ventilation into the space during the summer months, secure nighttime cooling as well, and the advantages during the winter months, it can also provide a mixed tempered fresh air to the particular spaces. So this is also designed to meet all the acoustic requirements of BB93 for the UK, whereas the noise levels can't go above 35 dB. So we've designed the system so it can maximise the ventilation performances through the low energy fan while still being within the required noise levels. So if you want to look at some further information, and also we have a PDF user guide available with the step-by-step guide, which is available by clicking on the read user link. Let's bring this into view here. And this just it'll provide you some further information, overviews about the HTM system. So along with the main design performances, it also works by using an intelligent, fully automatic control system based upon the room temperature and CO2 levels, as well as the external temperature levels as well. So the system is capable of being run fully automatic, varying the level of natural ventilation or fresh air supply into the room without the users having to do any control or interrupt their daily life to adjust ventilation levels and the requirements. However, obviously some people do like to have a little bit of self-control on the level of ventilation coming into the room, so obviously within that we can also provide manual override inputs, so if the user wants they can increase the level of openings to the space, increase the fan speeds, or turn the systems off completely if they want, if they're feeling it's getting it too cold below their preferred levels of comfort. So for further information, we also have details of, so we have some details of the Priority Schools building program and what the design criteria is met. And obviously you can also visit the Monodraught website where we can provide you with product cards and brochures about the systems, and just give more information about the units, and also some case studies of what we've provided before. So it's a background of the systems and capability. So with the units, key features, we have two different sizes available. So the HTM FS is the large system. It's a 500mm depth. This can provide a maximum daytime ventilation capability of 360 litres per second, and a 530 litres per second for the summer nighttime cooling. So during the summer, when you may need to, when it's warmer outside, we can then have the system running to purge the space out of any warm stale air that may have built up during the day, so it's nice and fresh and clean air ready for the occupants the next day. And then the second system is the HTM FS. This is slightly smaller at 300mm deep, and obviously with the smaller fan, each system has a daytime capability of providing 180 litres per second, and then 250 litres per second during the nighttime purge. And obviously, whereas, for example, touched on this later, but for a standard classroom, we'd be looking at one HTMF per room, whereas with the FS units, we'll be looking at two systems to get the same level of ventilations. We've got some, again, more background information about positionings, how the system operates, and the control strategy. And it also then provide more detailed information, a little bit more, going into a little bit more detail about each step for the navigator. So this is available to, as I said, open for you to read through later on when you're going through the navigator for the first time. So with the navigator itself, we start off with a little bit of background information about the systems here. And obviously the first step is to ensure you have prepared your IES model, ideally with all the geometry constructed, internal room profiles for like occupants, lighting and equipment, as well as assigning the building constructions for the externals, walls, roofs, etc. So that's all already prepared to run the simulation without any ventilation systems in there. So once we have that, generally a good idea to make an archive of your particular project before making any further changes. So in the event that you may experience any problems, which can happen in a lot of software, you've then got a clean backup to revert back to for future reference. So if you click on the link there, it will automatically bring up the link and press OK once you've selected the relevant file. One of the requirements with the navigator is once you've completed each step, you'll need to tick the box, which will then load up the next step of processes. Because if we scroll down here, you can see that some of the other steps are greyed out and you can't load them yet. So yeah, make sure you tick each box after you've done each step. So to import the HTM systems, you've got two methods to do this. So you can either click on the link within the navigator, which will then load the components from the library. Alternatively, at the top of the screen, we've got the Add Components from Library button. Both will do the same options. If you go through the Add Components from Library button, you'll then need to go to the drop down and select Monodraught HTM, which will then load up these specific systems. So within this we have a little preview of the system, of what it looks like. Again, some background information about the systems, as well as a link through to the system product card should you require some further information. And this is available for both units, just to give an illustration of what they look like. So if we select both systems, for example, and then click Import Components, it will load in, and then that will grey out, which will mean the systems are loaded into your model, and then we can close this up. So we can then tick the next step. Within the new release of IES, we now have the function of being able to quickly and easily duplicate and adjust the properties of the performance components. So it's down here. We've now switched to the Monodraught HTM grouping scheme. That's not available generally. Most of the time you'll be down as the spaces illustrating the various rooms, so it's just a case of going to the drop down and selecting Monodraught HTM. With this grouping scheme, we can then, if we say right click on what the particular component we want, so if we want to adjust the quantities of systems for each system, for each unit, we can then right click and then go to duplicate, and this will automatically create a copy of that same component, rather than having to go back through the component library to then import a new version of the model. As I said, the main reason you might want to do this is if within your model you have different sized rooms where you're going to need different levels of ventilation. So with the FS units, it's a small system anyway. For a standard classroom, you're going to need, say, 2 systems, whereas for, say, like a small group room or meeting room, you may only need a single system. Whereas if we then increase the sizes of the rooms and go for a lot larger areas, we may need to increase the number of systems to 3 or 4 HTMs. So this is an easy way of then getting those duplicates through. So now we've made the particular copies, we can then again right click and go to Properties. This will bring up the Component Properties window, and in here we can adjust the quantity. So as standard for the FS unit, we'll be looking at 2 systems operating as a primary and secondary. So operating simultaneously within the room is effectively like 1 unit. So for this copy, we just want to adjust this to say have a single HTMF unit, and then we can just change the labeling so it's nice and clear. So that's going to be 1 system. Again, for the other areas, we can go Properties. Want to keep this at 2 systems. You can adjust the quantities and click OK. So back within Navigator, we've made some copies and variants that we can tick that off, and then adjust the HTM operating components. So click that, and we can go Edit Properties. Let's bring up that same window, and again within here we can also adjust what systems are going to be, or what building elements are going to be working in conjunction with our HTM system. Now within these systems and the controls, we can operate additional natural ventilation louvers for the summertime ventilation, as well as provide window indicators on our wall-mounted controllers to help show to the end users when it would be a good idea to open the windows, or when they can open the windows, or need to close them off to get the best amount of ventilation into the particular space. So for the time being, we're going to leave louvers and windows ticked, but obviously for some instances, such as inner city areas, or where you're adjacent to main roads, or even under airport flight paths, natural ventilation might not be an option due to the external noise levels. and therefore it may be a requirement that the full ventilation to that space is then provided through the HTM systems, for example, and in that case we just need to select off, untick the louvers and windows to say that we're not going to be using those in this particular instance. But for this particular model, we're going to leave them ticked in because we're going to set them up with these additional items. The other new feature in here is to automatically identify HTM openings on room assignments. Now, this is go to the information, it will provide you some additional information, but this is a new feature where once you assign the rooms, once you assign the HTMs to the particular rooms you're serving, the software will automatically assign the relevant opening profiles to the louvers and windows that are needed with our HTM systems. So it saves us a step for you down the line to then go through and manually assign all these. So generally we'd probably advise keep that ticked as well, just for ease of process. Once we're happy with that, we can just click OK, and obviously with this it goes through and asks us to edit and check the properties for each of the components that we have loaded into the model. So once we are happy with the properties of the systems and quantities, we can then tick that off, and then we can start looking at assigning the HTM properties into our model. So with the HTM units, they're going to be facade mounted and require a external wall for the supply ventilation going through. So for this, we have, with the two different sizes of HTMs, we need generally two different sizes of wall louvers. Although with this, obviously, in reality, we can adjust the size, have different sizes of louvers to possibly fit in with the aesthetics of the building, such as sizes of windows, window frameworks. But as a sort of bare minimum for the HTM-F, we need a minimum size of 0.45 meters squared overall louver. So it generally equates to around a 900 by 500 louver. And for the HTM FS, we'd need two louvers at 0.27 meters squared. So that'd be about 900 by 300. Obviously, we can adjust those sizes in reality for the actual installations if they need to be slightly large, slightly wide, or slightly taller. It would just be a simple case of having a transition on the back there to drop it into the right size for the HTM connection. So it's basic information now. There's also a link in the navigator to take us to the specific page of the user guide as well, which again give further information about the HTM louver assignments and their requirements. But one thing I would say, if you do have a particular model and they are quite different sizes, if you have any questions about whether a particular size of louver would be suitable for a particular project for the HTM systems, then please just get in contact with us at Monodraught, and we can advise accordingly whether that be suitable or not, or what sort of minimum requirements we need to meet for that. So moving on to the assignment of the HTM systems, we then want to assign the selected rooms to the HTM units. So we click on the link, so we want to save a copy of the model there. And then to do this, we can simply either select the particular rooms in the model space and going through, or we can use the properties windows down here with the list of rooms. But one thing we want, just going to show is with the louvers here, we just want to, if we go to Model IT, we just want to drop in a few windows into the particular model. So over here, we're going to be looking for the HTM FS. So we've got a width of 0.9 by 0.3. So we just want to drop these into our model. Again. So there's 1 and there's 2. So that would be for the HTM FSs. And then over here, what we're going to be looking to do is we want to utilize, because it's going to be for example, IT room, so there's going to be more equipment gains and heat gains in there. We're going to be looking at 2 HTM F units, just to provide that extra level of ventilation. For this particular unit, we're going to be working in conjunction with some large natural ventilation louvered panels as well. So to drop the systems in here, we're going to do the other method. So I'm going to drop down to surface mode, and put in some construction lines previously. I'm just going to add the doors in here. So on here, we're going to do the 900 by 500 for the HTM Systems, like so. And then the louver panels are going to go below, which would effectively replace a glazed window panel. So that is constructed, and then what we can do, we can just check the properties quickly. So we've got the door, and then we can just set these quickly to a net vent louver, and then the same over here, just to illustrate the method there. So if we go back to the navigator, so if all the louvers now created into our model, we can then assign the selected rooms to the HTM Systems. So for these particular rooms, we're going to use the HTM FS, like a standard classroom. So we're going to want 2 systems. So select the particular rooms. Over in just below the navigator, we then do assign selected rooms to room groups. This will bring up the new window. In the grouping scheme, if you don't have Monodraught HTM automatic pair, just go on the drop down and it should be there to select. And then below, we just then select the relevant HTM system that we want to use. So we want to use the FS times 2, click OK, and then that automatically brings in. So for these two, as we're going to be looking more at IT rooms, we then want these to be the F units. So if we click OK, but obviously as we've got 2 systems, we might want to check the properties, so we're going to go increase that to 2. So at any point you can go back and reassign things. So for this, we'll just reload those back onto the room just to make sure it loads up properly. There we go. And then for these 2 rooms, we're just going to have them down as small group rooms. So here we're just going to have a single HTM FS unit in there. So that's the systems assigned. And then as you'll see on the model down here, a number of the windows and louvers have been assigned colours to them. This is basically to indicate that they have been automatically assigned the opening profiles that are brought in with the HTM unit. However, should you need to change those, it's quite easy to do. So in here, we'll just go the assign louvers and windows to HTM. Again, save a copy of the model. And this brings up the new feature for assigning the louvers with the HTM unit. So as you also see, there are small drop-down arrows on each of the windows and doors within the models with our HTM units. So if you click on the arrow, a small drop-down will appear, and then you have a couple of different options to select. So we have the external door and HTM louvers, and then select the relevant option and automatically assign. The other option is using the browser down the bottom left, so you can just open up the particular surface, select the item you want to change, and then at the top of the new list you'll then see the option to assign the HTM opening type to that. And then the third option is using the opening section and assignments button in Model IT. I think this was released in the 2016 version. So rather than having to go through and do each element individually, we can then go through to mass select opening types throughout the whole model and assign them over as one go. And on the assigns, rather than just having construction and macro flow, you then have the option for type, and you can again select the relevant opening from the drop-down list. So if we go to illustrate, so if we zoom in on a particular room, so on here we've got the HTM integrated louver, and this corresponds to the louver that would be directly connected to the HTM systems. And the other options is we have a HTM exhaust louver. This would be typically, say, like a small louver matching size to the HTM louver, but behind this would have a motorized damper and grill, and it would almost act like an exhaust outlet on the opposite side of the rooms. So, for example, if we had a HTM F unit in here, we could change that to exhaust louver. And if you look closely, once you do the selections, the little icon where the drop-down arrow is located will also change, just to help illustrate the differences that have been selected. So you'd have the supply air coming in, showing the arrow going into the room, and then for a typical exhaust, you then have an arrow pointing out. But for this, as we've got the FS units, we change that to integrated louver. For the third option that you saw there, we'd be looking at, go to the drop down, this would be a natural ventilation lever, so this could be like at the large lever panel, for example, down here. So it's basically just look at providing the natural ventilation into the particular rooms. And then it'd be the same with the windows here. So again, you can either have them selected as a fixed closed window, in which case there's no colours, or the other drop down to have them sort of opening in conjunction with the HTMs. It will then provide the colour output. So as you can see here on this particular room, we've only got one FS unit. We've only got the single lever that's being shown, and then the lever on the other side, we've just got it as fixed shut, so non-operational. Down here, we can obviously see once we've done that, we can also just ensure all rooms are checked, make sure they're valid, and as you'll see, if there are issues, you'll then get a little warning error message appearing next to the Monodraught logo. If you hold your cursor just over the side of that, it will then open up a little window just telling you what the levers are. And the most common one is not having levers assigned into the particular model that's needed. So if we can try and select the assignment tool, so we go to type and HTM integral louver, and for some reason that is not working. Always seems to be the way. So if we can do, if we unassign this and then try and manually assign this quickly to an opening. And the same with the louver panels, actually. So hopefully when we... No, okay. So that's an issue we'll just have to have a quick look at later on. It said these warning messages, they won't affect the simulation. So if you do have any there, you will still be able to run a full thermal modeling simulation throughout, rather than getting this error message causing you not to run that simulation. So once all the rooms are all made properly and there are no messages there, ignoring this particular room for the moment, unfortunately, we can then, the final step to assigning the HTMs is just to create the Apache HVAC network. So we create the new network, so you type in your the name that you want and click OK, and that will then automatically create the network that's needed for the system. If we go to Apache HVAC and then go open, and this is the networks associated with those three systems. It's all, as with some of the other components, it's all pre-assigned and made, so you don't need to go and adjust any sort of control parameters or settings. It's all pre-made and preloaded, so you don't need to just show this for your own sake. Now, should you then, of course, obviously some people don't, some of the users might not have the Apache HVAC module. Should you need this, probably have a word with, speak to IES and about possibly purchasing this this part of the module. Otherwise, if you get in contact with us at Monodraught, we can provide you with details about the alternative method for modelling the HTM systems without the HVAC module. Just go to the building template module quickly. And this is basically through the air exchanges within Building Template Manager, and we just set up two different profiles here. One for the summertime ventilation rate from the fans, and then the second one for the wintertime ventilation rates, which then also allows for a basic temperature profile of the supplier, just so we're then taking account of the air mixing. As in wintertime, we don't really want to be bringing in the cold air direct from outside when it's, say, sort of 0 degrees or even sort of -4 or 5 degrees outside. So if we go back to the navigator, so once we have the Apache HVAC system created, that is basically the final step to assigning your rooms to your model, and you're basically ready to run the simulations. And then the other steps down here are then just carrying out the suncast simulation, and then the room loads and system loads. This is similar to the cool face system components, and what we generally do is, if we leave all these as standard, as the default settings, and just click calculate, and then this will automatically run those calculations through for each of the particular rooms. Yeah, as I said, do that for room loads and system loads, and then finally carry out the thermal simulation. So you create your name of the results file there, your particular weather file, and then obviously make sure you have the Suncast, Macroflow, and Apache HVAC links ticked. And then you can select your modeling period and then simulate. And then there's one I prepared earlier. So once you have the system results there, we can go to the particular weather file and then select the relevant room. If we go to the dry resultant temperature, for example, we can then check what systems are working. So as you can see, we're maintaining a sort of temperature low in the low 20s during the winter months. So this would be down to, would vary depending on where your heating set point is for the particular room. And then we get then during some months getting a lot more sort of variation of the temperatures when we're obviously getting warmer temperatures outside. To ensure the systems are working, if we scroll down and then go to Apache HVAC Air Supply, we can click here and then check the results. And then down here we can see that the systems are working. So we've got the wintertime ventilation rates working through, generally around the 300 mark during the wintertime, and then during the summertime, again, around the same marks for the 300 mark for the daytime ventilation, but we then have the nighttime purge going up to 500 liters per second. Now you can see that the nighttime purge isn't happening all the time, so this also has to do with the control settings. So we make sure that although we're running the systems at full speed during the nights, we want to make sure we're not sort of overcooling the space and sort of making it too cold for the occupants in the day. And should you also wish, we can then want to carry out further detailed analysis. In the drop down on the left hand side, we can go to the HVAC network, and then in here we can then start looking at the flow rates through the systems, temperatures and CO2 that are provided into the room. So we can, within this, we can carry out some quite detailed, or you can carry out some quite detailed checks and how the systems are working. For the natural ventilation side of things, so we can have, if we scroll down, we can look at the natural vents. External vent, there we go, the macroflow external vent. So within this we have, or the control parameters within the set that are brought in with the HTM systems. You can see that the natural ventilation opening, so the louvers and the opening windows, are generally just pre-assigned to operate during the summer months or non-heating season. Although you can see down here in sort of end of March we've got some openings, and also in sort of October, because within this we also have the external temperature set point, so we can say if we do experience warm weather during the winter months, which you might generally expect around sort of beginning of sort of late March, early April, and also into October, you might get some nice weather. Then we can then automatically include for the natural ventilation air supply into that. Obviously, for the rest of the year, where it is quite cold outside, and you don't really want to be bringing in the sort of cold air into your room, because in case you cause discomfort to the room users, obviously the systems will automatically make sure those are closed. So all the ventilation there is then provided through the HTM systems with the air tempering. So that generally runs up the HTM assignments within your particular model. I said it's only a few steps to run through here, so once you're used to it, it'll probably take just a couple of minutes just to load and assign the HTM systems and the properties to your particular rooms. I said we've got the user guide available for you to view and talk through, which gives some more detail each step and some background information about the systems. But if you require any further information, then please do get in contact with us at Monodraught. So shortly after we've finished here today, we'll also be uploading a video to run through the steps, just to give another explanation of the step-by-step processes, and this will be available for anyone to view. So you can view it as many times as you want, just as you go through. That is basically it for the Monodraught HTM system. One of the questions we've had already for the HTM systems is about the use in IT spaces. Obviously within here we have modelled an ICT room with some higher gains. And obviously with the higher heat gains in the particular room, we'd obviously need to increase the level of ventilation coming through to the particular room. So for an IT classroom, we'd probably be looking at 2 of our HTM units. So you'd be looking around 600 litres per second ventilation rate to that air supply. Obviously, the requirements will vary depending on the total level of internal gains. So if it's a lot more, then we may have to look at increasing the quantity of systems to that particular space. Otherwise, if in this instance here, we may be quite restricted to the space on the external facade that we can use. You may not want 3 or 4 systems all on that one facade, in which case it might be an idea to then use the HTMs in conjunction with another sort of mechanical cooling or air conditioning system, so that the HTMs will operate for, say, 80% of the time, but then during the remainder 20%, where it might be sort of quite warm weather outside and you're going to need that additional cooling, then the HTM, the air conditioning or mechanical cooling, can then take over and then help dissipate those additional gains and get it down to the target temperatures you want. In terms of the criteria and making sure that the systems are working to how you want, obviously it will depend on the particular design criteria you're working to against, whether that's the UK's BB 101, SIPSI Guide A, or even some of the new release of the BB 101 criteria, or the TM52 criteria, which is the adaptive comfort criteria. So it's just a case of going through the results and checking the criteria, checking what you're getting against that design criteria. So now briefly we're just going to go on, run through the other systems that we have available to us. So we also have within the components library, if we go up here, we also have the Monodraught cool phase system. This was released quite a few years ago now. So we've got the 3 different size systems we have. So the fascia unit is a white clad system, which can be located in that exposed location of the of a room. Otherwise, the suspended ceiling option will be located within ceiling void and sort of obscured from view. So similar to the HTM system, you can just select the particular systems that you want and import components. Otherwise, within the navigators, again, go to the partners and Monodraught core phase, and as the precursor to the HTM, again, we have a step-by-step guide to assigning the systems, as well as a user guide to give further information about the systems, what they do and how they work, and then again just a couple of simple steps just to importing the systems. Again, it uses the ApacheHVAC module within that, so it's fairly nice, quick and easy just to assign particular rooms or unassign them to your particular rooms. And again, in the results file, we can then check this using the sort of dry resultant temperatures against the design criteria you're working against, the room CO2 levels, as well as the ApacheHVAC supply. So as you can see here, obviously again during the daytime, we could be, for the cool phase, we're looking up to around sort of 250 litres per second for the daytime, and then getting up to around 280 for the nighttime purge function. And one of the more original components that we've got available as a performance component is the Winkat systems. Obviously, as these were one of the more sort of original performance components that were brought into the IES software, we don't have a navigator for this. But again, if we go to the Add Components from Library button, and then Monodraught wind catchers. We have a full range of systems available here. The more recent ones are our XAir systems. So again, it's just a case of ticking the relevant item and checking the import components button. So here's a model we've created earlier. Now, with one of the main problems with the wind catcher command compared to the call phase and HTM is that it actually creates a new bit of geometry within your model. So it's a little bit harder to then, if you then need to increase the size or decrease the size of the system, we then have to go through and delete the systems. So if we go to right view, if we select systems and delete, for example, you can see here that we have a chunk left out from where the duct of the wind catch system was integrated into the room. So then it's be a case of infilling that with another small room and then merging it back into to repair that geometry, and then reassigning, dropping the system again. So with to assign the wind catcher components, we'll show on one of these JSON rooms. If we select the particular room that you wish to serve, drop down to the room level and then go component. If we go to the plan view as well, then components, it will then bring up the place component window here, and in the drop down we can then select the relevant system we want, so say XAir 140. Now the plane height is the height of the system. If we go to the right hand view, is the height of the system at the base of the external roof terminal here. Now one of the key bits to remember here is this point here wants to be located slightly taller than the highest point of the room. So for this particular room, if we go to the right hand view, we can see that it's a slightly pitched roof, and if we check the height of here, it's approximately, we're looking around 4 meters from height. So if we go to the plan view and components, so this one I want to go for, say, 4.2 meters, so we're going to go 200 millimeters above the top of the room. Rotation, generally, so you can then rotate the systems round to see a particular angle of the building. If you then got a room that isn't, say, sort of north, south, east, west geometry. So for this one, we're going to leave it at 0. For the X, Y, and Z scaling, our recommendation would be to leave these as standard, so that way it is dropped in at a one-to-one scale with all the relevant performances in there. And then the duct length, this is the area in red, so it's indicating the wind catcher duct, so we want to ensure that this drops down into the room. So for our particular model, we've got 200 mm above the room, so if we say ½ meter long in duct, we can place the system onto the room. If we go to the right hand view, we can see we're a little bit close onto the roof there, so if we check the roof there, we can see that we're not above the tallest point, which is going to cause us a problem when assigning the system. So if we go to component, if we put that to 4.5, increase the duct slightly, place the component, just check it again in right view, we can see that we're above the tallest part of the room and the duct drops down into the room. So plan view, select the system, and up here we can then get a new button, finalize component, and job done. So that is the system loaded in. So you can check it's taken a chunk out of the geometry here, which shows the duct is connected. We have the door assigned, which is the modulating dampers. If we go up, we can then see that the system's up here. And as with the HTM systems, the wind catcher component will come complete with all the constructions and modulating profiles already pre-assigned to the component, so you won't need to go and then create the sort of automatic modulating profile for those systems. We're already pre-assigned. So once you just connect it and finalize the system into your room, that's the system then completed for the units, and you can then run the simulation. Just quickly for the results, in terms of checking the ventilation going through, one thing you can do, go to the in Vista Pro, go to the macro flow opening arrows, and then you can see on the particular model, if you go to the wireframe view, it's a little bit busy, but you can then view the systems and the change in ventilation rates that's going through each quadrant of the Winkat system, so you can check that it's operating. And then for the particular room, as the air is going in through the Winkat system, which is actually another room, you'll need to check this through the macroflow internal vent. So you can then see here that the ventilation is going through, so it's internal vent rather than external vent. So I think on here we've got some sort of restricted opening windows at the top here within the room, which is where we're getting some additional ventilation supply. So yeah, as with the HTM and cool phase, we again have a user guide available for the Winkat system. I'll just bring it up here. So again, this should be available through the through IES. It just gives you a brief summary of the systems and how they operate for the cool phase system, and for the Winkat systems. So I give you a brief summary of the systems, how they operate, and the basis behind them, and then again a step-by-step process of how to drop them into a particular model. But as with the cool phase and HTM, if you have any sort of queries or additional problems with a particular model that you're working on, then just feel free to get in contact with us at Monodraught. You can send us a copy of the CAD file and sort of explain your problem or what you're trying to do, and we'll be more than happy to put the systems on or give suggestions of what size systems would be needed, and to then pass the model back with the systems already on there. So we're drawing to the close here. So we've gone through the HTM system in quite detail and a brief overview of the cool phase. But if anyone's got any sort of questions, then sort of let me know now, and I can try and answer them in the time remaining. Otherwise, drop us an email at info@monodraught.com, or direct to myself at ian.grant@monodraught.com. And I can obviously try and answer those questions. So some of the questions we've got already about how to check the right size of wing catches for your room. So obviously this is a little bit difficult, as it's creating and sort of cutting out geometry of the particular room. Again, within the Vista results, you can then check the temperatures and CO2 levels within your room you're modelling against the criteria you're modelling against. So if it's not providing enough ventilation, the temperature is still quite high, so we then need to increase the size of the system, or if the units are overperforming, then we can then obviously look at reducing the size of the system to that particular room. But it should be noted that the room heights will have taken account of the size of the system. As if you have, say, like a 2.5 metre size system, you won't want a really large, say, sort of 1 to 1.5 metres squared system serving that particular room, because you can get a lot of airflow in a small space. And our recommendation would be to have a larger quantity of smaller systems, so you're getting a better distribution of airflow going through. There's also so I answered this earlier about using the HTMs to computer rooms with high heat gains. Yes, we could potentially do that with the HTM systems, but it depends on the internal heat gains to that particular space, and how much space on the space you've got on the facade to fit the systems in. But it might be a possibility that for quite a lot of high heat gains, it'd be a case of using the HTM systems, or even the cool phase system might be more appropriate for the IT spaces with the phase change material that's within the cool phase, which can then provide a sort of more cooling to the particular systems rather than just a natural ventilation or sort of tempered mixed vent air ventilation to the units. Also had a question about sort of the modelling lighting systems in IES. At the moment, we're sort of currently in the process of developing some, or trying to develop a new way of modelling some pipes within IES, and we also have the option of using a hybrid system using some pipe Lux Loop units, which incorporates a LED lighting system that goes around the Sunpipe system as well. So I said that's currently in development. So as soon as we have sort of any sort of more details about the component for that, we can obviously let you know down the line. But that sort of draws us through to the end of this webinar, unless there's any other queries. But hopefully this gives you a nice little sort of overview of the HTM systems. Obviously the guys will give you the more detailed information. But yeah, if any other further queries, then just let us know. And thank you for joining us. We'll, as soon as we process, we can get a run through the partially out the video of this tutorial as well, webinar of what's gone through, as well as send you links to the brochures and product cards that are available for the systems on our website, and also the more in particular the YouTube videos for the which runs through the process of assigning the HTM systems, as well as the cool phase and Winkat systems for those that might be interested. But thank you. I think we'll shall leave this there for today. But any further questions, and please get in contact with us. Thank you very much.